Hello everyone and welcome to today's webinar, SCSI is Dead, Long Live SAN, coming to you from beautiful Eden Prairie, Minnesota, as well as Englewood, Colorado, both located here in the USA and brought to you jointly by your friends at Help Systems and our partner, Dynamic Solutions International. So today we're going to be talking to you about Storage Area Network Technology, or SAN, and even though my guest today represents one of the companies in this marketplace, we're going to keep this discussion product agnostic as much as possible so that you can learn what this technology means to your data center. External storage in this, or in our marketplace, is catching on, however slowly, especially on the low end, but it's really here to stay. You really need to get to know it. You need to understand it and not be afraid of it. This is really mainstream technology now. The pricing is very attractive, and the additional functionality that SAN gives you in terms of shared storage and replication, they're both very attractive, and it really doesn't matter what size data center you're in for your IBMI. This is technology that you should consider. My name is Chuck Lisinski. I'm the Director of Automation Technology for the robot product line here at Help Systems, and over the years I've had the opportunity to help many of our customers automate and monitor their IBMI systems, and I'm very pleased today to be joined by Chris Bremer, Chief Technical Officer from Dynamic Solutions. And Rick has a long background in external storage, and I've found has a great passion around the topic. So good morning, Chris, and how about a short introduction?
Good morning, Chuck. Thank you. Rather than blabber about me, more about DSI, as you mentioned, we've been doing this for quite a while. We're a 43-year young company, been in the storage and technology business, actually quite a bit longer than most of the big names you see out there, and hopefully you learned something useful from our presentation today.
Awesome. Thanks, Chris. Appreciate that. As mentioned, if you do have any questions during today's presentation, please feel free to chat those questions in. This is what our agenda looks like. We're going to, first of all, take a quick look at a marketplace survey that Help Systems conducted last year and some interesting things we found out about SAN technology. And then we're going to move right into Chris's topic. We're going to talk a little bit about disk storage management at the very end. So a question that we posed during our marketplace study last year, which was released early in 2015, and by the way, we're conducting a new one that just opened up about a week ago and will be released pretty much at the first of the year, was, are you using external storage with your IBMI? And if you look at the numbers, first of all, 75% said no. A small percentage said yes, we're using IBM DS8000, V7000, we're using some kind of IBM SAN, and then we're also using, about 7% said we're using other SAN technology. And then we combine this question a bit with BIOS technology, virtualization. Another one of the advantages of using SAN technology is being able to do that virtualization and share that storage between servers. And the numbers basically reflected, okay, if you're using BIOS with that technology, you are using most likely SAN technology. So it appears as though there's really a tremendous opportunity for IBMI customers to get into the SAN world. So that's what we're here to talk about today. And Chris, I'm going to turn things over to you. If you click once on your screen, you'll have full control.
Okay, thank you, Chuck. Let me just start out with a little introduction of why we're giving this presentation. In the last few common and other user sessions that I've attended, we've been asking the question, just as Chuck said, you know, what do you know about SAN? What you do know that it's, you know, a technology available on the IBMI. It is how you connect a number of peripherals, and basically what we found is a lot of people really don't know what a SAN is, the basics around it. So this is not a sales pitch. This is purely a give you some useful information so that you can go and talk intelligently with vendors as far as some of the devices you might want to connect into your IBMI world. So again, as I mentioned earlier, DSI has been around for quite a long time. We're not actually new to the business. We've been doing it since 1973, which puts us, like I say, older than Google, Apple, most of the companies that you might be more familiar with today. We kind of refer ourselves as a 43-year-old startup. So we're always trying new and exciting things here at DSI. But let's talk a little bit about what we're really here about. We're going to talk about SAN. We're going to talk about fiber channel and some of the hardware and topologies that go into it, and a little bit about ports. But don't worry, we are not going to get into massive technical detail. I don't need to put you to sleep this early in the morning. All right, so what is a SAN? SAN is the acronym. We are in the computer industry. We do like our 3-4 letter acronyms all over the place, but SAN stands for Storage Area Network. And that last word, network, is one of the first places that people get confused. It is not a network in the traditional term of I'm going to plug my internet cable into this and make it work. Generally, a storage area network is its own independent network, and we'll talk about the different topologies and connectivity that we use in this environment. It's very high speed, as we'll see, and it's normally used to connect to peripheral devices, not generally communication devices. So disk, tape, virtual tape, those are the types of things that you will normally see connected in a SAN environment. So what isn't it? I can't tell you how many times I've had people confuse SAN and NAS. They look a lot alike. They use the same 3 letters, and they're backwards. But NAS is network attached storage, and in this, and a NAS does use similar network and topology that you use in your IP environment. You use internet cabling. You use TCP/IP type of thing to talk to your file server, which is storing files at what we call the file level. A SAN, on the other hand, storage area network, works purely at what we call the block level. In other words, rather than retrieving an entire file when we are accessing a particular file, we're only returning n number of blocks of that file up to the operating system as they are requested by the various applications. So when SAN, we use the term fiber, and there, again, to dispel a lot of the confusions, you'll see fiber spelled 2 different ways, F-I-B-E-R versus F-I-B-R-E. And what is fiber? Is it the stuff that we're all told we need to get more of in our diet? And the answer is obviously no. What does that have to do with technology? Is it something we make our clothes out of? Again, no. And this is where there's an awful lot of confusion. Is it a type of cable? And again, F-I-B-R-E is not the type of cable. That is an F-I-B-E-R cable. FIBR fiber channel is actually a protocol standard. It is the definition, just like TCP/IP, that defines how information is transferred between various devices in a SAN or fiber channel type of environment. So where did all this come from? I mean, because in our world, there tends not to be anything that is absolutely new, but something that grows from previous technology. And a lot of what we have today came from what we know as SCSI, Small Computer Systems Interface, even though they worked on some very large computers as time went on. But SCSI, as we all loved or hated, depending on how long you've been doing this, had some real limitations. It had very, very short cable lengths. If you ever have had the issue of wiring cables between different components within your computer room, it had very, very limited speed. That's why if you remember in the picture there at the very bottom, you see that the big fat, what we call a SCSI 1 cable. I hated those things. If you ever had a clip fall off and it never really sat correctly on the connector, you'll know that there were, and the cable was as, thick as your thumb, so it didn't want to bend around a corner very well. Those things were a real problem to use in daily life. It got better as we got up into the higher density cables, but they still didn't go very far, and they still had very, very limited speeds. The very end there was 320 megabytes per second, which was quite fast for those days. For modern technology, not very fast at all. But that doesn't mean that everything that we did when we developed the SCSI environment was wrong. We actually developed quite a solid protocol as far as what the command structure looked like when we were talking to disk units or tape units. And so we used that command structure, what we call the protocol stack, and used the SCSI commands and then layered them on top of new hardware technology. So in essence, if you were to go and look at the commands that were used when you use the old SCSI cables and you look at the commands that are used today in a SAN or fiber channel environment, they would look very familiar, and are still based on the same basic technology. Do note, if you ever had somebody give you the big long presentation on what the stack looks like for a networking environment, often referred to as OSI, these are not the same layers. They are not the they don't call them the same thing, but they are a stack of protocols, the physical, the interface, all the way up into the SCSI command layers. But these are, rather than optimized for a communication environment, the SAN and these protocols are totally optimized around storage. It's all that they're meant to do is interact with hosts and various storage devices, again, like disk and tape and virtual tape. So what devices would you need in order to build a SAN environment? Well, the first part is a connector at the host side, a host bus adapter. These will vary depending on the type of host you have, depending on the age of the host. And then there will be various cabling and connectors, and optionally we will have switches that will be involved in setting up various topologies within the SAN environment. Let's look at a little of those. At the very bottom, you'll see something we mentioned, copper. Early in the days of what we thought of as fiber channel 1, or the very early days of fiber channel, there was an option to use copper cables instead of, at the time, more expensive glass cables or fiber optic cables. That's pretty much gone by the wayside today. Today, almost everything in the SAN environment is what we simply refer to as glass or fiber optics. They come in various types of cables. Within a building, or even within a near-term networking environment, you're going to use something called a multi-mode cable. Older cables tend to be what we call the 62.5 micron. They're still out there and in use today. They work just fine. But almost everything today is in what's called the 50 micron, used in almost all of the newer installations. Most of the adapters can use either cable, but if you're new to implementing a SAN environment, you're almost always going to be getting groups of that. You see in the lower right, you'll see the picture of the orange cable. You'll see piles of these orange cables around it. SAN environment. There is a different kind of cable called a single mode cable, and this is the type of cable that is used primarily by your phone type companies when they're running cables very, very long distance. They can now run some fiber cables without regeneration close to 40 miles or more these days. Generally, again, used by the telcos as opposed to individual customers. Those cables have connectors, obviously, on the end, and there are various and sundry connectors. Again, the older one you see at the bottom is copper. Copper, as I said, got expensive, and glass got less expensive, so you almost never see the copper connector anymore. Early on in what we thought as fiber channel 1, again often referred to as the 1 gigabit days, there was something called an SC connector, and that connected to the laser ports on the different devices, also known in those days as GBICs. Those aren't used anymore. You rarely see those unless you find an older system today. For the 2 gigabyte and up, everything has gone to what's called the LC connector, and that's for everything 2 gigabits and above. It's a little smaller connector, which again is a test for somebody who says they know everything about SAN and the various environments. So one of the questions I get all the time, well, SC for small connector and LC for large connector. No, it's reversed. LC is actually the smaller connector. The SC and LC stand for the companies that designed the connector, not the size of the connector. SC is for Siemens Corporation. LC is for Lucent Corporation. But keep that one in your back pocket if you're ever trying to figure out if someone actually knows what they're talking about. So you'll see, again, for all of the newer environments, it'll all be fiber optic cables with the LC type of connector. And we'll go into greater detail in a little bit, but basically the other component that you may or may not have in your shop is one or more fiber optic switches. And these switches are from various vendors, and they sound just like what they do. They allow interconnecting of various hosts and devices, just like you would do with your networking switch, but again, primarily oriented around fiber optic networks. Okay. The key thing that these switches do is very much like what you would do with a network switch where you were looking to do some secure environments, is we would use these switches to isolate various componentry in a SAN. So it's not everything sees everything type of environment, but as we'll talk about in a little bit, the switch allows us to isolate various componentry within our environment. So how fast does this stuff go? Well, the very, very first SAN environment ran at 1 gigabyte per second. Now, if you really look back in time, you'll see that they kind of almost ran at 1 gigabyte per second. And these were in the early days of the standards. Not all of the devices talk to each other. A IBM device might not interact with a storage tech device or something like that because they were still working out a lot of the standards. By the time we got to the 2 gigabyte environment and we got to the new connector, and we had finally gotten the hardware, software, and firmware to be pretty standardized across the environment. Today, if you were to go out and buy equipment, you would be buying equipment either in the 8 or the more current 16 gigabyte per second standard. And we've got plans, and they're already working on the protocols and devices to take us from up to 32 and then all the way up to 128 gigabytes per second somewhere down the road. Now you'll notice way off on the right-hand side of the screen, normally when I'm giving this presentation, it's on the left side when I'm turned around. I call this out in the left field. There were some people that were annoyed that the 8 gigabyte standard, the time difference between 4 gigabyte and 8 gigabyte came out, tended to be a lot longer than some people liked, and there was a group that tried to go out and do a standard away from the normal standards group called the 10 gigabyte standard. There were actual devices made in that environment, but they pretty much died on the vine when nobody else supported them. So if you ever hear of that, you know, if you find stuff on eBay that says 10 gigabyte per second, don't buy it. There isn't anything that talks to it. Okay. Topologies. When you talk to someone about a SAN, one of the first things that people will be asking you about is how are you connecting your various devices together? What is the topology that you're using? This, at the simplest level, is what we call point-to-point. Basically, you take a cable, connect it to your host bus adapter, and you connect it directly to the device. It's a one-to-one connection. Essentially, the SAN recognizes that this is point-to-point. There is no addressing involved per se, and they just talk to each other. You'll see this, and again, because we love our alphabet soup, you will see this quite often referred to as SCP2P, point-to-point. Seen a little bit, but not as heavily anymore, is something called arbitrated loop. Okay, in an arbitrated loop, we connect our host adapter to a device, but then that device may connect to another device, and we run essentially a loop. If we went back to the picture of our cable and connectors before, you'll notice that there were 2 connectors for every cable. That's because the laser, if you will, is simplex in communication terms. It only goes in one direction. We don't reverse the direction of the signal. So the laser only fires out one of those fiber optic ports, and the answering signal comes back on another port. In an arbitrated loop, we use the outbound signal, or light beam, if you will, to go from device to device to device, and then back around when the various devices have talked on that bus back to the host. This may look similar or familiar to a lot of people who go back and remember the token ring days of communications, where devices would get on the bus and there was a token that was passed to them that said, yes, you can now talk on the bus. It is somewhat similar in architecture to what's going on here in an arbitrated loop. When devices are put on the bus, if they are in what we call soft addressing mode or soft alpha, each device is allocated an address on that bus in an 8-bit address. And again, you don't see this very much anymore, but in the early days when some of the HBAs and devices didn't talk well with each other, we used to do something called hard alpha, in which we hard address that device so that you know, they talk better on this loop. Again, you don't see that too much anymore, as almost all of the devices and protocol standards have really get solidified. The last topology is what we call the switched fabric, quite often just referred to as fabric. And in this environment, each device will be assigned a 24-bit address. And that's because, as you can imagine, with 24 bits, we can have quite a few devices out there. The picture shows you at the very simplest level where we have multiple hosts and multiple devices, but it could be many, many hosts, many, many devices, and actually a tier of switches. Again, very similar to a communications network in that we can have a tier of switches talking to each other. And we'll get into that a little bit more as well. Okay. If someone starts talking to you about a SAN environment, they may start using a lot of terminology about ports F ports and L ports and X ports and things like that. Do not panic. All of those ports are for when you're getting actually down into the device itself and interacting. They're not necessarily needed for you to talk to plugging in a device at one end or the other. All devices have what we call a worldwide name. As you see in the lower part of the screen, it's a very long set of numbers. This is very similar to a MAC address that is assigned by the manufacturer, and this number is assigned by the manufacturer as well, and it's the only real number that is needed as far as device talking to another device, and primarily only needed when you're doing a fabric environment so that you know what devices you're talking about. At the port name, it's called a worldwide port name. At the device name, it's a worldwide node name. And when you're using a fabric environment or a switched environment, there's a term called zoning, which is important because this is how we isolate various devices to each other. If you have multiple hosts and, say, multiple tape drives, you don't want all of the tape drives to be seen by all of the hosts. The hosts get confused. The host will say, oh, wait a minute, I see that drive. No, I see that drive. No, I see that drive. You use zoning to isolate a device to a particular environment. And you'll hear again terms called soft zoning and hard zoning. As the technology has evolved, most of the new switches don't really see a difference between the two. They see everything as a hard zone, which actually locks various devices out in the various environments. And this is a little more graphically clear. You can see that when we zone an environment, we just basically lock certain devices, nodes, if you will, into certain ports. So what would you use this for in an IBM I environment? In the disk environment, as Chuck's survey early said, right now most people are using just the inbuilt storage pools, but you can add auxiliary storage pools, and one of the ways you would do that is in a SAN environment. You can add virtual tape libraries. You can add tape drives. I mentioned LTO6 in this environment. LTO7 is getting ready to hit the streets here in the not-too-distant future, so many changes in our disk and tape environment. And what if you want to know more? Okay, a lot of people will pull up a red book to say, I need to find out more about this topic. There is a book, a red book on iSeries and SAN environment. Unfortunately, it was last written in 2005, and I wish they would update these things. It's now 2015. Many things have changed. The first two chapters are good as long as you ignore any reference to any kind of part or model number within that book. If you really have insomnia, you can go to the standards group, the T10 and T11 groups, and they will tell you more than you ever wanted to know about. T10 will tell you about the actual messaging protocol that's used at the upper level. T11 talks about the hardware that we just talked about in this environment. And again, I would encourage you to at least the red books are free. You can go down and like I say, just read the first couple chapters. It's like 400. The book is 400 pages long, but only the first about 40 or 50 are what are useful.
Yeah, all right, Chris. I've got a copy of that on my nightstand, I believe.
You must have insomnia.
Well, and I want to mention just a couple things. First of all, we've got a lot of educational material on our website around independent auxiliary storage pools. So if you're interested in learning more about that technology in relation to SAN, a lot of material there. Also, one of the reasons that we've partnered with Dynamic Solutions is around a couple of our automation solutions for IBM I. And the one I just want to bring up today real quickly is robot space for disk management. When you're working in SAN technology, you're working with large amounts of data, large amounts of storage, and we've got a beautiful solution around that in our robot product line called Robot Space, which continually monitors the disk space from kind of a 30,000-foot view. It also does very granular analysis and statistical collection from your disk usage over time so that you can do analysis around trends, what's growing, what's old, what needs to be cleaned up, and the tool also has built-in cleanup routines as well as notifications. So if something does get out of control, you will know about it. And I'm going to open a polling question, and the question is, are you using SAN technology with your server, and would you like some additional information on any of these technologies? So just to recap, SAN technology is here to stay. It's growing. I know that Dynamic Solutions is doing very well in this area. And if you do have any questions, please feel free to email either one of us, either Chris or myself. Our email addresses are listed here. And that brings us to the bottom of the hour and the end of our webinar. Chris, I really appreciate you sharing this information to our IBMI community, and everybody have a great day. Bye-bye.